This episode is brought to you by WeatherGuard Lightning Tech. At WeatherGuard, we support design engineers and make lightning protection easy. You're listening to the Struck Podcast. I'm Dan Blewett.
I'm Alan Hall.
And here on Struck, we talk about everything aviation, aerospace engineering, and lightning protection. All right, welcome back. This is the Struck Podcast. I'm your co-host, Dan Blewett. This is episode 50, so the big 50 today, closing in on our 52. We'll have completed a full year's worth. In today's episode, we're going to talk about a pretty dramatic lightning strike that hit a cockpit during a storm over South America recently. We will talk about some good Boeing news. 787 Dreamliners are back being delivered. Southwest has placed a really big 737 MAX order. We'll also talk about Rolls Royce's new gigantic, potentially world's largest turbofan. We're also going to talk about two really unique in our designs in our EVTOL segment. One with the Talon, it's called the Talon System, and it's actually a sort of a lifting, it's basically a two-part where one vehicle is going to lift it, then separate as the aircraft takes off. So pretty complex. I'm sure Alan will have some intense thoughts about it. And then we're going to talk about some new Lilium news, them releasing a 7-seat EVTOL and also confirming their merger with Qell. So Alan, how are you, sir?
Good, Dan. Boy, it's been a crazy week in aviation. A lot of things are starting to pick up, but hopefully we're going to start seeing the world economy start to turn around as everybody gets vaccinated and the airline industry can pick up. But there are some positive signs happening, which are always good.
Yeah. Well, I was on a plane a bunch this past week and a half, and most of the flights are, pretty darn full. Of course, I'm sure they're condensing their schedule, right, to make that happen, so it's more financially viable. Yeah. But they're definitely not doing the every other seat, which I know you've taken a lot of flights in the last 6 months. And I took one, I think, back in October, November, and that was, I think, still kind of sparse where they had a lot of middle seats open. But it seems like it's definitely shifting in the right direction, financially.
It is. And the last piece of legislation that was signed by Congress or signed by the White House is pumping money into the aviation community, especially the airline community. So you're seeing a lot of recalls. People that have been laid off are being brought back to work, which is fantastic. And that'll tend to spur further developments and, get the airline industry moving again as people get back to work and there's some cash influx into there. Hopefully by the summer, when I say summer, I mean like July, August, things are clicking along at least to 50% of where they would be. That would be good. And then, it just grows from there, but we need to get going.
So first on our list today, a Boeing 737 was struck flying over Panama. And it's pretty crazy. You can see this little 2-minute video where, the sky just lights up and you can see the bolt sort of hit the cockpit. Alan, is there a big difference between where lightning strikes on the aircraft? As far as, at least from where a passenger is concerned, do they care if it hits the wing or the cockpit or the fuselage?
Most passengers don't notice when the aircraft has been struck by lightning. And that's just because when you're in the airplane, it doesn't tend to be as loud or noticeable. You may hear a pop, but it's not like you would think because you're so close to it. When you hear a lightning strike on the ground, it's extremely noisy and extremely bright. In an airplane, it doesn't tend to be that way. The pilots are the one who typically notice them, particularly in this particular case, because the lightning strike happened off the nose and came right over the cockpit. So the pilots can get blinded by that temporarily because it's such a large flash. But that's the more common case. You don't see a lot of video that show that attachment to the nose of the aircraft and it's sweeping back over the airplane. That's a very common type of lightning strike and leads to a lot of repair that has to happen. When you take a strike to the nose of the airplane actually is flying through the lightning. So that lightning reattaches itself to the fuselage and into the tail if it lasts that long. So you get these little pop marks that happen all along the fuselage that somebody needs to look at and inspect and repair or buff out or whatever they're going to do. A strike to a wingtip, if you happen to be sitting on a window seat and you could see it, that's pretty easy to see. You see a lot of videos like that more recently because people have cameras on the phones. But the strike to the wingtip is pretty easy to fix because pretty much just the wingtips when the tail's getting struck. So you just got a localized area you got to go fix on the airplane versus these 50 little pot marks you're going to have on the fuselage. Yeah, that's the difference. Cost.
Well, I know all those things are obviously really scary for a passenger, where if you see the plane get hit, you're going to be like, do I need to tell somebody? You know, like it's like the old Twilight Zone episode where there's the gremlin on the does everyone know?
Can you see this gremlin out in the wing? Can you see it?
Yeah. That episode is still amazing. Timeless. So moving on, 787s, the Dreamliner, Boeing's, big boy, is being delivered again. It says Boeing still has 80 in stock or so, with 457 Dreamliners to deliver out of the 1,500 order. This is reporting from aerotime.aero. So obviously all their production is done in Charleston, South Carolina now. And this is good news for the company because they've had some production quality issues and that were getting to be a big concern.
Right. It caused a lot of chaos within Boeing to get the quality issues resolved. And then pretty much everything stopped. It would be a combination of there wasn't a huge demand for the aircraft. It tends to do longer routes. And when there are not a lot of longer routes being flown right now, and they had these quality issues, so it made sense to kind of shut it down and reboot it in a more consistent fashion. But they got to get going, right? I mean, you can't do that forever. You got to sell aircraft. And the 787 is a very good aircraft. It does have this sort of niche place where it does very efficient routes. So they, in terms of the South Carolina facility, they needed it to get going. So 5 aircraft hopefully will turn into 50, right? That it'll gradually grow over time again. But it's good to see that because that was the one airplane that you were worried about was not going to make it out of this coronavirus situation. That was the one.
Yeah, just because all the big planes, and we're going to talk about this later with the new turbofan coming out of Rolls Royce, but there's just not a place for international flights kind of at the moment.
No, until we can all agree upon who can travel, right? There seems to be this push to have some sort of vaccination card before you can travel internationally, but there are no systems in place to do it. So at the earliest you're going to see that, I think, is the summertime at the earliest. So those international routes are still going to be really slow.
So other good news for Boeing and, of course, Southwest is that Southwest has placed an order for 100 new 737 MAXs, and they have an option for 155 more. And we were chatting about this offline here, but, Boeing flies only 737s. What's the advantage of that, and why? So my other question, I have 2 questions. Number one, why be so bought into one aircraft? Because if they had a defect, wouldn't you be kind of stuck with it? Number 2, is there really a difference between like an I flew home on a American Airlines A320, Airbus A321neo. Is there really a significant difference between an Airbus in 2021 or a new Boeing plane? I mean, they both, I'm sure, have the best engineering in the world. This is kind of like, to me, Ferrari versus Porsche or Lamborghini. Like, is there really a significant difference?
There's not a real significant difference if you're a passenger on the airplanes. They basically fly you just as comfortably. Range is comparable.
Or uncomfortably.
Well, yeah, right. So, I mean, obviously
relatively speaking.
Well, the 737 is just an older airplane, right? So you kind of stuck with that tube size. And Airbus airplanes are in very well put together airplanes. I mean, they got a lot of bright, intelligent people putting those airplanes together. Same thing for Boeing, right? So they kind of honed their marketplace, and they all have their little niche in the world where they are very successful. The difference between the airplanes from a operational side, from an airline side, really comes down to the accounting office. All the little details of how much it costs to buy replacement parts and how often you need to fix the aircraft, to things like pilot training and all the little nuanced stuff that we as passengers never think about drive the success or downfall of airlines. They just does, right? And having 2 different aircraft makes have different 2 sets of pilots and 2 sets of mechanics, so to speak, and you have to be much more versatile if you're a mechanic, because you're going to be working on different airplanes all the time. So having one airplane simplifies things, and in theory, makes it quote unquote safer because everybody's just working on this one thing. But You see, the thing I see the most about the Boeing Airbus is sort of a political aspect to it, which is both companies are funded by their governments substantially, even though they say that they're not. They are on some level. And in the United States, Boeing's getting a big push from the federal government. In Europe, Airbus getting a big push from the European governments. That's what drives it. And then, China is a wild card, Japan, Australia. Those tend to be more divided. Brazil, is Embraer. So you kind of get this political divide that's starting to drive where airplanes are sold. If you're a smart airline company and you don't really care what airplane you operate, they'll leverage them. Like United and Delta will leverage the two, Boeing and Airbus, against one another to drive down the cost, the purchase price, and maybe the maintenance prices of the airplanes. They'll do that. But Southwest has taken a different approach. And so like Ryanair has done that differently. There's a couple airlines which are only one airplane type airlines, which have done fairly well. So the model appears to work. The question is, like, Southwest doesn't fly transatlantic, right? And it doesn't have any intention to. If you're United, you kind of have to do that.
Yeah, and one of the, I think, famous stories about Herb Kelleher, who was the founder of Southwest Airlines, I think someone came into his office and they're like, hey, we have this, we should offer this type of meal service or like this new thing. And he had basically one question. He's like, well, will offering this help us be the #1 low-cost airline in the world? And if the answer was no, then we're not doing it. So everything they're doing in Southwest has always been to be the #1 low-cost airline. So it seems when you start to view all their decisions in that vein, then it probably makes sense that, hey, we want to have a huge stock of parts that fit every one of our planes. We can always interchange it. Like you said, the mechanics, they're incredibly competent on this aircraft. There's no mix-ups. It's not,
Right.
How does this latch work on this plane? How does this baggage door close on this plane? I mean, it's just not that those are, important questions,
Right.
but everything is stable. They can just drop in, interchange people because they all know the same plane. They can move people around and
Exactly.
like you said, pilot training simpler and on all that stuff. So, and like you said, buying in bulk, being a big customer of Boeing is probably going to afford them some luxuries also as far as like feedback on planes or
Right.
griping about certain features that aren't working well.
A good example of this, and a more recent example of sort of the decision process that happens, when Bombardier built the C Series, which eventually became the Airbus A220, Bombardier has built sort of regional aircraft for a long time, and if the companies that operate those know how to operate them and know the foibles and the benefits of operating those things. When they built the A220 or the C Series, it's something completely clean sheet new. You don't know what you don't know because you don't have any service history. So from an airline's perspective, you're sort of taking this risk of, is it going to last as long as they say it is? It's got these geared turbofan engines, which I don't know much about. Do I have the mechanics and the infrastructure in place to handle them? And are they going to create additional problems? Don't know. And I think that really kind of hurt Bombardier in a sense that they didn't have that sort of Airbus or Boeing placement of, yeah, but we'll take care of it, right? Bombardier may not have had the financial infrastructure if there was a problem with the airplane to help a Delta operate it. So when Airbus was purchased, given that program, all of a sudden you have all this infrastructure that's placed over that A220 design, and it's a great airplane. Don't get me wrong, it's a great airplane. But having Airbus name on the front of it made it a better airplane.
All right, moving on to our engineering segment for today. We're going to talk about the new Rolls Royce UltraFan, which will be the world's biggest airplane engine, fan diameter of 140 inches, and seems to be fundamentally different in just like some little respects than the GE 9X, which is the current, largest jet engine in the world. So, Alan, what jumps out to you on this? And also, my other question here for you is, who does this plane fit? Because we've talked about the Airbus A380 has been, decommissioned, or not decommissioned. That might not be the right word, but they've been taken out of service, and
mostly, yeah.
So this is not going to fit a 737, right? This is a big jet engine. Right. So But with the international flights kind of being on hiatus, where's the UltraFan going to go?
Don't know. I honestly have seen zero press about where the end user is. And is it just a technology demonstrator that they're going to scale up or down, as the case is, depending what the airplane market demand is and where the next airplanes are going? The push is for larger inlets, slower moving inlet blades, hot section. So there's a cold section and a hot section. So the front of the engine you see when you're getting an airplane is a big, huge fan. That is the cold section. The part that's burning the aviation fuel is the hot section. That's where you see the exhaust come out the back end of the engine. So you got this kind of hot, cold section. So the most efficient design is to have these big, massive fan blades moving at slower speeds, cutting larger swaths of air and pushing them towards the back of the airplane. So as these engines get bigger and more efficient, you're going to see more colder sections, cool air sections of the engine moving with these really funky shaped blades, and then a hotter core that's burning fuel much more efficiently. So this Rolls Royce design is like walking through that design and trying to come up with a baseline where they can, looks like, scale it. But where's it going to go? And it's just like the worst possible time to be developing a huge engine like that when there's no international travel. What's next? Not like the 777X is like on hold, and 380 doesn't seem to be going anywhere. And where is this engine going to go? I don't know, because it's such a massive amount of cash that's being burnt.
Yeah.
To set this up and run it, and to use it as a quote unquote demonstrator with no home for it. Whew. Wow.
Yeah. Well, and again, reporting here by Aerotime Hub online, but Simon Burr, the chief of engineering and technology at Rolls Royce, said that basically because of the pandemic, they're pushing their service date for this from 2025 to potentially 2030. So this is a long way off. I mean, they're saying this will be ready in 10 years. And if there's a new plane or new demand, then they could potentially launch it faster. So yeah, it seems like they're aware of that, and it's just an interesting time to be in the engineering world. I expect, especially as these things are trying to just get bigger and bigger. And, we talk about this in our wind turbine podcast, that, wind turbines are getting bigger and bigger and bigger, but the pandemic has no effect on them. So it's not like suddenly they have these huge ones that need to go into storage or just need to be slowed down, where the aircraft industry is just very different.
Yeah, it totally is.
To put it lightly.
Yeah.
So moving on to our EVTOL segment today, the first one I want to chat with you, Alan, about is the Talon System. And this is what's striking to me, is that even now, with so many companies like put their hats in the ring here, there's still new crazy designs coming out. There's like, you think they'd start to sort of hone in, and I know that the helicopter is a pretty consistent design, right? There's not like crazy new wacky helicopter designs. We talked about earlier in the year this one that's, that has a record-breaking speed. Like, they're doing new things to make them more efficient and more powerful, et cetera,
Yeah.
but they still look like helicopters.
Yeah.
EVTOLs continue to come out with crazy new designs. So this one by the Talon System by Talon Air is basically has a lifting drone that will bring the aircraft up, and then it'll get up to speed, I guess, is with its propulsion system,
Right.
and then take off, and that lifting system will then return, essentially as a drone, will return to its base to be charged for another lift or landing.
Right.
I mean, how does that strike you? We've talked over and over and over. You're the certification guy, that you're like, that's hard to, you should have a talk show. It's like, that's hard to certify. The whole audience yells it, right?
Yeah, it's because that's what it is. It's really hard to certify something that it's the two pieces that comes apart that are flying in tandem, which it just seems like there's so many downside risks to that the FAA and EASA would have a hard time creating even a certification basis for it. I don't know how they would even flight test it. Like, what do you do in flight test? What sort of conditions do you put it under? From a drone standpoint, when it's no people, unoccupied aircraft, okay, cool. I mean, I get it. It makes a lot more sense because it's much more efficient than carrying around these booms, which are only used for vertical takeoff and vertical landing, and then carry batteries in them. Because once you get going in forward flight, you really don't need them anymore. So you want to dump them because of the aerodynamic drag and the weight cost. So that doesn't, conceptually, it makes a lot of sense, but it just doesn't pass the muster of of a certification approach. How are you going to certify it? Because I think in a lot of cases, and I think where you're getting to the heart of, Dan, is that you see a lot of different eVTOL designs that seem certifiable, like they can in a sense could do it, but they vary so much. You got to wonder, like, one of these designs is not going to make it, or most of these designs are not going to make it, because aerodynamics of aircraft are pretty well figured out by now. Propulsion systems are kind of figured out by now. So what feature or what advantage are you providing that we haven't known for 50, 100 years now? That's a really good question, because those companies haven't, a lot of those companies haven't answered that question. Like, what is it that makes you worth $6 billion? I don't know.
Well, this one's interesting because it purports to solve a lot of the problems that you've discussed, which is you burn up a lot of your battery energy lifting the darn thing off the ground. Like, that's really energy intensive. Yeah. And so this one says, hey, we're a two-piece, so this one has its own energy system, this one has its own, so it's going to come up, let it go. It takes care of the extremely energy intensive section of lifting it up, and then it'll just go back down and charge and wait for the next flight. That seems to make a lot of sense. Yeah. Obviously, and then you're reducing weight because that's not going to stay with the actual passenger craft as it takes off. Right. So there's a lot of, and then you're not going to have to buy, if you were to buy a fleet of 100 of these, you don't have to buy 100 with all the vertical takeoff and landing, propulsion system. It's only going to be on like a couple of the lifters, right? Right. So those seem like the big pros in this pro column, but I mean, what are the main cons here?
Well, think of it this way, Dan. Think of it like the Falcon 9 spaceship, where there's parts that return and parts that continue on, right? It's set up, the thought process is very similar to that, like in a rocket, where at some point, this is just dead weight, we need to get rid of it, and they drop it off. So that part, from an engineering standpoint, makes sense. The wild card is that we're not test pilots for flying in these things. That's where the difference comes, is that passengers are not test pilots. People that fly to the space station, astronauts, are test pilots. They know what they signed up for. And I when you get to all the little variances that come in these designs, you're just like, man, it doesn't seem like there's a way to keep the passengers safe. Because from just a business standpoint, that first crash is going to kill you. It will crush a company, and that's why a lot of these designs are going to hone in on eventually wing designs that are very inefficient, because the vertical takeoff and landing piece is so energy costly. Like you were saying, it's such an energy user, massive energy user, that you don't want to be there in any length of time. And maybe the short takeoff and short landing is the way to go for the time being. That may end up being what the answer is. We don't know, because and Dan, I think you pointed out this a number of times, like, we just don't know. We haven't seen anybody really take off one of these things, or land one of these things, or fly 30 minutes in them. So nobody knows. Nobody knows.
Yeah. Well, that's a good segue to our last topic for today, which is Lilium. So they have merged with Qell, which Qell is just a SPAC. So it's not like some other, it just bears explaining that, because SPACs are like this new thing. They're not new. They've been around for a long time, but they're just sort of very in the public eye all at this moment. People are trying to understand what they are, what they do. Basically, Qell was the SPAC, the special acquisition company, or special purpose acquisition company, led by, this one in particular, led by former GM President Barry Engel. And so they've merged with Lilium, which will allow Lilium to become a public company. And so Lilium has announced a new 7-seat version of its Lilium jet. And again, this goes back to the same thing at a time when no one's proven that a like 2-person one can sustain flight for as long as it needs to and show the range. So, I mean, how do you feel about them suddenly rolling out an even heavier, bigger version of the EVTOL?
Well, it makes you wonder if the Uber vision of carrying people from the local pizza parlor to their house or place of business is not a workable model, and everybody's starting to realize that, or maybe there's somebody in that space like a Joby that's in that space that you're really not going to compete with. So you need to be thinking more business aircraft type service, where you're maybe going several hundred miles and you have 4 or 5 people on the airplane, and you just need that kind of commuter bus type aircraft. That's where some of these companies are going, right? And they're going to that sort of that 9 to 19 passenger regional aircraft market as another potential place, because we know, for one, that business jets and business aircraft are a viable market because they've been around forever, and we know the operators in that space is, the King Airs and the Cessnas and the Embraers that operate and the Lear jets that operate in that space. That market is known. You know how many operators there are. You know how many aircraft there are. You know what they're paying for those aircraft. You may be able to grab some part of that marketplace because you have a more efficient, greener technology. On the commuter side, you know what those aircraft are right now, right? I mean, it's a CRJ type aircraft that are in those marketplaces, or the turboprops, the Bombardier turboprops, Dash 8s, that kind of thing. They're in that marketplace that you could basically adapt an existing airframe, make it electric, and serve that market. And in a lot of places in Europe, you could really do that because the distances aren't all that far. So you're seeing this sort of segregation happen in terms of where these companies are focused at and where their potential marketplaces are and where they think they're going to be able to make revenue from. It's really hard in all those spaces to make any money. It really is, because there's so few aircraft companies that actually are profitable. So making the SPAC, and you know more about that space than I do on the investment side. The SPAC to me is just like a vehicle to pour money into to fund the thing. But the risk doesn't go away, right? That risk, because you have a SPAC and you're opening up to a broad set of investors, individual investors, will allow you maybe to generate more cash to do the design and get it implemented. But that downside risk is still there, and it's such a huge downside risk. It's going to be easier for an Airbus or Embraer or a Boeing or one of the existing aircraft companies to enter that space than it will be to start off to design a new airplane that flies 5, 7, 9, 19 people. It's just so difficult to make that profitable, as we see, right? And we just don't see a lot of companies entering that space in the fuel burning dinosaur fuel space. You don't see a lot of new entries there. You don't.
Yeah, that's an interesting idea. So basically you're saying that they want to stay small enough where they're not going to encroach on that bigger aircraft space, because like you said, Airbus could easily throw the money at this.
Oh, yeah.
Or Boeing could easily throw the money if they're going to get into that, hey, we're carrying significant passengers now.
Right.
And they've got the resources to do it.
Yeah.
Yeah, that makes sense.
Yeah, and it's in that commuter market where Mitsubishi struggled and Bombardier struggled in that marketplace, that maybe there's a niche in there you could squeeze into right now. That's where a lot of this is headed, it looks like.
Yeah, well, so this was really good reporting by EVTOL.com, which they do a great job. So if you're interested in this space, always be sure to check out their website.
Yeah.
They just do a fantastic job with the EVTOL news. But they're talking about the batteries, and they say they've got batteries that they're testing that are higher watt hour, and beyond the 250 that's kind of standard now. They're trying to get to the 320 watt hour per kilogram batteries. And these are going to have 2,000 pounds of batteries in one of these planes, it sounds like.
Yes.
So it's interesting as you hear the energy density start to go up. Obviously, I know you're a big fan of the hybrid propulsion systems, where you've got, like we talked about, the Honeywell, their new turbo,
backup system, essentially. Yeah.
Yeah.
Fuel powered backup system. Yeah.
And that still seems like, if you're going to start to put more passengers into that seems to be even more so like potentially the right choice for something like that, where, all right, we got 7 instead of 2 passengers or 7 instead of 4. If the hybrid propulsion system worked for 4, why wouldn't it still be the right choice for 7? That's sort of the question I'm asking myself as I just read this from an outsider's perspective, right?
Right. That's a good perspective to have. I think the issue on any Honeywell, it does, or a similar company, it doesn't matter who, is that I think the thought process right now is if I can buy a set of batteries and I can buy a set of motors, I can make the propulsion system myself. I don't need a Honeywell, right? Honeywell is very knowledgeable, and GE and Rolls Royce are very knowledgeable in burning fuel efficiently to create electricity, and that's what an APU does. So they know how to do those things. If you're trying to drive the cost out of a program, they tend, if you're sort of new to this, you don't want to try to bring in a Honeywell because it's going to cost you money. So you think, well, I can do that myself. This is the one piece of the aircraft I can do myself and save myself some money. The problem is it's the one piece of the aircraft where you're likely to fail too, right? So is it a better situation to bring in someone like a Honeywell who has a lot of knowledge in that space? And it may cost you a pretty penny to put that system in, but it's going to deliver the aircraft. Those are trade-offs you have to make, and that's where the battles really lie, is like, what is the cost of that system versus the chance to get in the marketplace? That's where the decisions are really becoming real.
All right, well, that'll do it for today's episode of Struck. If you're new to the show, thank you so much for listening, and please leave a review and subscribe on iTunes, Spotify, or wherever you listen to podcasts. Check out the WeatherGuard Lightning Tech YouTube channel for video episodes, full interviews, and short clips from the show. And follow us on LinkedIn, Twitter, Instagram, and Facebook. Our handle is @WGLightning. Tune in next Tuesday for another great episode on aviation, aerospace engineering, and lightning protection. Strike Tape, WeatherGuard Lightning Tech's proprietary lightning protection for radomes, provides unmatched durability for years to come. If you need help with your radome lightning protection, reach out to us at weatherguardaero.com. That's weatherguardaero.com.